So in previous session, we discussed about MVC. Every application will have two portions. If it is a full stack application, we will have front end, back end portion. Front end may cover by Angular or React or simple HTML. For back end portion, we need to write three types of classes controllers: service and repository. Controller job is to read data. Service job is to write or accommodate business code. Repository will help you to insert data into database. Insert, update, delete, or select. Okay, we understand this is how MVC, in MVC we follow. Instead of clubbing everything front end, back end code together, we will write a clear logical blocks for easy maintainability, readability, right? And we can achieve dependency injection, loosely coupled classes, and they will follow solid principles also. Single responsibility, open close, all that we can follow if you follow MVC. Otherwise, it is not possible. Okay. Now coming to Spring, which modules are helping? For controller part, security and Spring MVC, Spring Web Flux, for reactive based applications and for non-reactive based. And coming to cover transactions, Spring transactions, any emails if you want to send, Spring Mail, for scheduler stuff, Spring schedulers, AOP, for more reusability, for CRUD operations, Jdbc, Hibernate, JPA, all this. And by using these modules, when you cover these implementations, obviously you need to run your classes on IOC containers. All these classes are managed by Spring only. Okay. Anyway, this is we discussed. Even last two videos also, if you refer, you can able to understand. And these all are the Spring Cloud concepts for microservice based implementations. Now, I'll go through types of applications that you can support. After learning this, right, the types of applications, I'll use this one only. Drive only, let us use. Sir, I'm learning Spring Boot microservices, right? What I can achieve, what kind of applications I can implement. Maybe you can.
Backend applications using Spring.
No, but basically, let me come to the discussion. Generally, right, if any static application required, let me categorize applications into two types first. Okay, application types. You also may have idea or you may not have, but let us discuss this first. Because we are learning something and we don't know what we are going to do with that. Correct? We are putting efforts to learn Spring Boot, but what I can achieve, what it is capable for. Application types. Applications can be static. Static applications. Dynamic applications. Static applications will not have any backend. And even if you want to let's say you have a company website. There they used to put most of the static information. If you refer any company website, right? Mostly static information. In case if they need any registration page, let's say arbutech.in. This is my company website. I don't have any dynamic logic in this. This is completely static. No dynamic logic to bring this content here. In case if you need login, I have a login page here. Email, password, verification code need to enter. Then once you click on login, it will take you to some other different dashboard. So this is the dynamic content. Whenever I want to log in, maybe you need to sign up first just by filling all these details. Then when you go to login, using same email and password, you can able to log in. These two pages are dynamic. And all the content which you see here is very much static. And if you ask me the sign up and login integrated with backend, no, not yet integrated. So the whole page is static page. The complete page itself is a static. For this one, no backend, no server, nothing is required. I have a domain and simple HTML code. This is all simple HTML code. Simple HTML, CSS, and JavaScript also you can use. Where it will run, backend is not required. No server required, first of all. First, static applications. How it will run, sir? This application deployed. This application is deployed into some free repository, Git. My code is there in Git. Directly from Git only it is loading. Directly from Git only, that static application you are seeing. Do I need to buy for it? Nothing. It is open source. It is there in the Git. Just the static application I know I just committed into Git. And I just given my domain. I brought a domain from, GoDaddy, Big Rock. So many providers provides it, right? I got a domain www.arbitech.in. I brought this domain and simply configured few configurations I have to do. In Git, I did that configurations. I need to configure CNAME of this website domain, which I brought. GoDaddy will sell domains for 99 rupees also per year. You can buy a domain and create a static application, deploy it into Git, and link it to your domain. Hardly in 30 minutes, you can build your own website. For that one, no backend, no server required. Why? Because the static app contains basic HTML code only. Who will run HTML code? Any idea? HTML, CSS. I used only HTML here. CSS, JavaScript. What is the server to run them? If it is a static application, browser only. Browser will have HTTP, DOM, HTTP, HTML code, CSS code, JavaScript code run on your browser only directly. Code is here in Git. Whenever you try to type your endpoint or website URL, the basic landing page it will pull. The code only will come to your browser. If it is my browser, when I enter www.arbitech.in, whatever code is there in the GitHub, that code came to my browser. That code came and my browser did that conversion, code to this view. The code became view and you able to see here. The code become view and you able to see here. Just the code will come to browser. The code all the way it will travel from browser to Git to browser. In browser, when I enter, I able to see this. I'm able to see my website. Basic, simple, static content. But coming to dynamic application, the story is different. Sir, what about Angular? For a static apps, can I have an Angular or React? You may have once you convert your Angular code into JavaScript. If you compile and convert your Angular or React code into JavaScript, maybe you can do the same. You can load it into Git and use it. But generally, we prefer Angular React applications to integrate with the dynamic backends. Basically, we use them for dynamic applications. You need not to put lot of efforts to build static applications. Simple HTML is there for you. You can build it. Now, coming to dynamic applications. Dynamic applications definitely requires backend support. Only your browser cannot handle everything. Let's say here coming to sign up. If I do sign up, if I enter all the details here, I'll enter all the details. And once I click on submit here, this information I want to permanently store. If it is your browser, I given this endpoint to you, you entered all these details. So it is running in your browser, but the details I wanted to see from today onwards, if I integrate it with the backend, or else this information, if I wanted to store in somewhere else, if it runs in your only your browser, and if your browser only keep that information, how I can able to know who registered, when registered? So somewhere that information I need to store. So I need a backend support. Let's say in the static app itself, I have a registration page. I have a registration page. Registration page I have. Anyway, that registration page also you can design in HTML, CSS, JavaScript that can load here. Similar like this. Simple registration page example I'm taking. I have a registration page. Now when I click on submit button on that registration page, if you want, keep that information into database. If you want to keep that information into database, any DB or any flat file, if you want to store it into file, generally we use DBs, right? To keep information secured. So generally we use DB only. Yeah. Now this information, if you want to store it into database, you need to build a dynamic app. Front end is already designed by using HTML. As I was telling you, right? It can be a simple HTML, CSS, JavaScript, or you can use Angular, React. Now this is my registration page. When I click on submit button on this registration page, it should go all the way to your backend. In dynamic app scenario, I'm telling you, okay? Backend. For dynamic apps, the main backbone components are backends. Backend. So there is this registration data. Once you click on submit, it should go to backend. Then backend can do all these database integrations, storing into database. Sir, I want to send email, sending to SMTP integration, send mails. I want to send email, whatever backend operations. Sir, once registration done, I want to receive email as admin, one email, and whoever registered for them successfully registered something email, welcome email, I can send. All backend APIs will have that support. Even if you want to send email from JavaScript also you can send. That's a different story. But to handle database operations, all that stuff, you can do it in backend. And permanently information will be stored here. In future, if you want to, if you want to log in, you can go to login page, enter email password. So that login details also will be handled by backend only. So after registration, I have a login page. So login validation, how it will do based on the registration details only. So based on the registration details only, login also will be handled. We'll come to backend app. Backend app will verify in the database whether he is already registered or not. If registered, then you can go to login success page. So it will send login success page. Once upon successfully login. So that's where you need backend support. So which technologies we have for this backend? So many technologies. We are here to learn Java, that too a framework, a simplified framework to build dynamic applications. And it is a simple example for registration. Okay. So such backend applications, what are all the examples that we have in the industry? What types of backend applications you can build? Simple web applications. Simple web applications you can build, particularly by using Java. Even before web applications, standalone applications also you can build. Standalone web applications. Scheduler based applications. Scheduler based Scheduler based applications. Distributed applications. Distributed microservice based applications. Okay, now I'm talking about Java only here. Other technologies for implementing all this, we have so many. .NET, Node.js, PHP. There are so many. Only I'm telling you few popular. But Java is very strong for especially enterprise business applications because it is having security, lot of stuff is recommending enterprise applications to use Java only, mostly banking applications. Not alone single domain. I see all the types of domains. banking people, e-commerce. I saw the major e-commerce applications, insurance applications, telecom applications, everywhere Java. I have been into all the major domains. Majorly, the backend portion is covered by Java only. To handle large volumes of data, other technologies are not having such support. So that's where Java is using. Okay. Coming to standalone examples, standalone applications, you can have simple standalone applications using CoreJava. Right? CoreJava is having swings concept for GUI designing. If I can show you here, calculator, a standalone application in your Windows PC. You can see a standalone application in your Windows PC. You can build this by using Java swings concept. Simple drag and drop tools will be provided. You can create this GUI quickly, and backend code you can write based on this operators, plus operator, minus. Very simple. So here technology, core Java you can use. In this we have swings, AWT's concept, something JWT, not JWT. Other concept. I'm not able to recall the new concept. It's okay. So using any of these, you can design that GUI, and backend code you can write by using your simple core Java operators, all that stuff. Simple such standalone applications. You can implement examples. Let's say I don't want any internet. Just to manage my shop, I have a medical store, I have a general store. I want to maintain my products information. I got a stock. Freshly, I opened a shop. I got a stock worth of 10 lakh rupees. Different products. All that products information I want to maintain, sir. Then each product, when I sell, I want to generate a bill. And when it reaches to low stock, the minimum stock I want to maintain is 10 pieces. If it go below 10 pieces, the system need to give notifications to me so that I'll bring that stock and top up in my shop. So for that one, I want simple product management system. Any product management system, it is applicable. Any shop, any inventory, any warehouse management, you can implement by using simple standalone. But that application need to install into that particular PC. We cannot access from web. Which is standalone, we cannot access from web. Same application in website if you want. I have not a single shop. 10 shops I have. I'm sitting at home and I deployed some employees. They will take care. I cannot go and see the stock into each stock PMS application, right? Product management system, to understand what is a low stock. Their employees will do their duty. I want to access all the data from the 10 shops, whatever product they are selling minute by minute, how much revenue I generated, how many products went to low stock, all that I want to see. So in that case, web application will help you because via internet I can access anything. So here to implement such web applications, you can use servlets, the old technology I was telling you. Now here we are learning Spring MVC to achieve it. The usual technology servlets, difficult to write. Spring, easy to implement. Easy to implement and a nice framework. Easy to implement. Your end-to-end use case, here also you may implement, but your application may not worth. But when you go with Spring, it follows all the best practices. You may not aware, but it will follow internally. And it will make your application more robust and performance side also, as it is providing. Yesterday I was telling you, right? Connection pools by default, they will impose. By default, they will implement when you use data JPA kind of concepts. So without you aware that there is a connection pool, you will implement application and your application will become very stronger. One of such example I'm giving. So your application will be very stronger and powerful enough like an enterprise application. But if you go with servlets, that is your headache. You need to take care of everything. So that's where we prefer Spring. So this is the technology that we use. Any application you can build. Example, any application. So I would say framework names I will put here. J2EE, Spring framework. And the old frameworks we have Struts, JSF. They are not as strong as Spring, okay? We can't compare them. Spring is a one framework for everything, whereas Struts, JSF are only for controller part only. Okay. Spring is for one shop. Everything you can cover in Spring. So the modules we can use to implement is Spring MVC, right? Sir, I have CRUD operations, Spring Jdbc, or Spring ORM data JPA. Usually we go with JPA. It's a very simplified enterprise level framework. We go with data JPA and you can implement your application. I told you, I showed you, right? Implementation of application will be on fingertips. Quickly you can finish it. If you know the complete scope, what you want to do. Implementation is very simple because Spring Boot managed everything. Spring Boot will do everything for you. The skeleton creation, tools we have, STS like tools. Quickly we can go and create application and we can host it into our backend server. As I was telling you, right, standalone applications. Quickly you can build, deploy into Git and you can access. Same thing, backend also you can do. You can implement in Spring and give access. So everybody can access via internet. We know how simple it is, right? Yesterday we deployed and I given access to you to access a page. My local mission, my mission itself, whichever mission I'm using, I made it like a server. But if you want to keep it live 24/7 without restarts, all that stuff, maybe you can buy a VPC or you can buy space in the cloud and you can deploy there also. It's depending on your budget. And what type of applications win web? All the product management systems, inventory management systems, school management, whatever it is, you name it, school management systems, any web applications like FB, Twitter, whatever you want to build, any news newspaper applications, whatever it is. You can build anything in web application. You will have full backend support. You can implement it. Charting applications, chatbots, AI chatbots. Right, nowadays your machine can be AI machine. You even not required any chat GPT. Open libraries are there. Deploy into your local machine. Use Olama. Your machine will become AI machine. You can, without even internet also, that library will help you to answer your questions. Means AI is at our doorsteps. We can start using it. You can train it also using training methods. Particular to your business, if you want to train, instead of training a person, you may remember or not, but AI will remember. You can train, and in future, whenever you ask based upon your training, it will help you. If you give data, daily sales data, everything information, if you give, and if you ask your AI, hey, what products are easy moving, on what products we are getting good revenue, all that information you may ask, it will help you when you feed such data into it. Okay, we are deviating. So web applications also we can build by using frameworks like Spring, or you can use simple J2W servlets, but that is very difficult to write. When I say framework will have all predefined. Mostly 95% of logic framework will provide. The 5% we need to contribute. Where exactly our customization is required, right? There we need to put our hands. Remaining 95% framework will cover. Such a beautiful framework Spring is. You can build any web applications. Scheduler based applications. Scheduler based applications. Spring is having the schedulers, Spring Quad schedulers, Quad JPI. You can have so many other open libraries also. I'm just giving you Spring reference only. So many open source libraries you may have. Spring Quad you can use. Along with this, if you want to do any CRUD operations or read operations, write operations, you may use data JPI also here. Sir, what kind of applications are these? Imagine in an organization, you will have a lot of applications. A big organization, if you take any organization, any domain, call it insurance, banking, telecom, e-commerce, different business streams itself they will have. In other words, I can say, if you are a joint family with 2 or 3 brothers, okay, you may have different business. Big brother may have one type of business, the middleman may have a different type of business. Within the family itself, you 3 people may have 3 types of business. One business. Now, coming to their children, they may not access to other parent or his uncle's business details, right? They will not share with them because though it is a single family, the business stream is different. Coming to any application, let's say e-commerce, if you go to Amazon.com, as an end user, we are seeing that the products page, the landing page, we go there and we search product and we buy it. But in the background, there will be so many business. people will work. So many strategies they will put. Seller side, seller's business team will be there. Customer side, customer business team. Delivery side, delivery business team. Completely they are a different business, but all together they will deliver you product for sure. But information they will not share. Between them also, there will be some limitations. For customer module, if any information required, they may share. But if seller asks, I'm a seller, I'm adding products into, I'm a seller or I belongs to seller domain, where I used to add my products and you people search and buy it. My domain may need not to have customers information. Customer information will be misused if my domain able to see the customers details. I may call customers directly and say, hey, why you are buying from Amazon, take it from me, I'll give 10% discount. I may mislead that information. So domain to domain, lot of limitations also will have. If any information required, if any such information, customers reviews all will be given to the sellers. How to pass the data, daily based reviews. I should not give direct access to the database to the seller module. So whichever seller module data sending, that data will come as a flat file. Customer module business people will tell to the seller module, I'll give you in a text file all the comments, and real customer IDs also I will not give. I'll say customer 1, customer 2, like that, and his reviews and the feedback details I will pass. So you read and send it to your seller. This is what review you got for your product. So improve yourself. If it is good, continue. So to read data from flat file to data need to read, and it need to be processed and save into some DB. Every minute I want to read that data, or every day at night 12 a.m. if the information is coming, during that time frame only at 12 a.m. I want to read data and store it into database. So seller will, when he logs in the early morning, he can see from the latest database what are all the feedbacks he received. How can I implement as such applications? Reading data from file and storing into DB. Do I need any web applications kind of stuff? Means not required. You can write code by using Quartz, JPA, purely backend this one. No front end, nothing. Nobody will trigger. Whereas in standalone application, web application, an end user will add data, or end user will pull the data and see the information. A event will be performed by user. But when it comes to this, nobody will touch this code. Automatically it should run. Such a automated alarms. Alarm is a different term. Automated scheduling we need to do. Automatically it should read data, and it should process, and it should save. Read, process, save. Need to do. You can use simple Spring quads here. Using Spring, you can implement such applications also. Do you guys want to add anything here? Are we good?
Yes, sir.
Following, or
Yes, sir.
is it boring?
No, sir.
Add me if you want to guys add anything here. Okay, out of my knowledge, giving these examples to you. Okay, if you want to add anything also add here. Distributed applications. Okay, generally when it comes to distributed applications, why application need to be distributed? The term is saying distributed application. Earlier, imagine when computers invented and when first Amazon.com started, there are very few customers. Hardly throughout the year Amazon might have sales of hardly 1,000 or 500 or 100. We don't know. Now millions of requests every day to every application. So when such huge hits coming, or when you have different business streams, yes, I have a banking application. I have a banking application which is having a customer module or online banking. When this distributed applications may require, as I was giving the previous example also, right? Information may be different. Loan banking, I want to start a new bank. I want to implement applications. Single application I cannot build because online banking will have a different banking logic, different strategies. Everything is different. Loan banking is different. Credit card banking is different. Trust banking is different. Loyalty banking is different. Again, coming to each banking, you will have again different set of modules. Coming to loan, home loan, car loan, automotive loans, insurance banking. They may have insurance sector also. So many modules they may have. And each module itself, again, in nowadays in microservices terms, if we talk, each application may have at least 5,000 microservices in the background. At least, as this is a big domain, I'm giving you example. At least 5,000. And at least they may have different teams. Thousands of people may work on each different category under that particular banking. Those are not like a simple student projects, right? Real-time, lot of data, lot of information, lot of categories internally. Again, it will have so many different teams. Okay, when you get an opportunity, you are not going to implement end-to-end online banking or loan bank. We will be part of it, some module. In that module, something we will implement. Now, if you have such a different banking applications, in case if they want to talk each other, generally if they keep all this into one single application, it will not work out. It will not definitely work out. So different, as a different applications, they will implement them and deploy it. In case if they wanted to talk each other, so online banking wants to read information from credit card banking, loan banking. Let's say these three applications need to be in sync. Online banking, especially when I log in, some bankings, right, will show you how much loan still balance you have, or are you applicable for instant loan. All that it will show. And your credit cards information, if you log into ICICI, there you will see all your debit cards, credit cards, loans, everything it will show, upcoming EMIs. Though they are different applications, your online banking will pull information from the different applications. How one application can talk with another application? There are so many technologies to handle that. Earlier, we used to use EJBs to do that stuff. We used to use EJBs. Using EJB, we can able to establish network communication, okay, using stub and skeleton model.
Remote method invocation, RMI.
RMI is a plain implementation, right? RMI, I don't know, people might have used, we don't know. 30, 40 years before.
Yes.
RM is a basic networking concept, remote method invocation. In your core Java itself, you have this concept, networking concept. EJBs,
Corba,
yeah, EJBs we can use, or yeah, you're saying Kafka, right? You may use something, different technologies here. Kafka to keep data and read, but in case if you want information in sync, maybe Kafka, it's a different thing, event driven. Synchronously, if you want data, Kafka may be not the choice. We can use REST APIs nowadays. This is very popular. REST APIs, SOAP APIs, web services we call, using web services. SOAP implementations we have, REST implementations. We can able to talk using the SOAP or REST APIs. We can able to talk. Mostly we use REST. For any security protocols, we use SOAP. Earlier, that was very difficult in EJBs. And technology dependent also, EJB. If I am using EJB here, this one also EJB, this one also EJB, everywhere should be EJB. Now, if it comes to web services, online banking, if it is implemented in Java, loan banking, if it is implemented in .NET, credit card banking, if it is implemented in Node.js, it's okay. One technology can talk with another technology. Cross communication is okay. Using REST API, you can talk via HTTP only, it will make communication. Every communication will go as a HTTP communication. So it is not a technology dependent. It will be independent when it comes to SOAP or REST. So like that, distributed applications we can build. All business applications are distributed only.
So the monolithic and distributed are same, sir.
Yeah. No, see, we can't say microservice applications also distributed, right? We are going into too micro level. Earlier, let's say online banking, again, it categorized into different applications. At least if an application is having 5, 6 modules, they used to implement it as a separate application. Nowadays, we are not doing that. You have 5, 6 modules. Earlier, the thought process, forget about microservices, I don't know. I will say, hey, we have 6, 7 modules we need to implement for so and so task. What would you suggest? When I ask you, will say, let's implement a separate application. All that 6, 7 modules, you will keep it into one application with the security, login page, sign up page, whatever it is required backend code, you will write and use to create it as one application. Nowadays, if the same requirement, if somebody asks you, business people, hey, we have 5, 6 modules, how do you want to implement? I'll say, implement 6 microservices. That is the thought process changed. Why changed? What are all the pros and cons? That's a different discussion. Monolithics are enough, right? Sir, why industry move towards microservices? What big advantages we have means? There are. Certainly, there are so many advantages. That's why we move towards 2 micro level applications. Okay. When it comes to microservices application, each application may have so many modules. Let's say online banking is having, let's say, one application. I was telling you a lot of applications they will have. Coming to one application in online banking, they have modules. Module 1, module 2, module 3, or I can say transaction module, fund transfer, customer logging, adding pay, add payee module, credit information module. Consider all such modules you implement it as one application. The project is only one, or module based project. You have project with all this code. Now the same application, if I ask you to implement in microservices, this may not be right example. Yeah, here microservice application. Why we should go towards microservices? Here we talked about technologies, right? Yeah, distributed applications using EJB or web services, we can achieve it. Coming to microservices, as I given earlier example also, if it is application, let's say the sample of Swiggy I given, right? Food to go application, FTG applications we call them, Swiggy, Zomato, Uber Foods, Uber Eats. There are so many, right? Now this Swiggy application, if it have modules, if it is a monolithic, as a module, we will implement customer module, kitchen, restaurant, delivery, and once the delivery also done, we go to help to talk with customer care if food is not delivered, food is not good, for refunds, help module, maybe chart API, that all implemented. Let's say all these part of one single monolithic application. You deployed into a big rack server, good RAM, good GPU, good CPU, everything is there. This is monolithic application. You deployed into a single server. You deployed into a server. This is your server. You deployed it. You deployed it. But the server threshold, maximum to maximum, it can handle parallel request, right? Parallelly, if I get around 5K, 5K request, can handle. Beyond 5K request, even if you increase the server space, RAM size, GPU size also, beyond one threshold, right, any machine will not respond because of network limitations. You may have money to buy server and you can increase it. Who will buy network? You may have network bandwidth also. But the motherboard or processor, whatever it is, it may have few threads can process parallelly. There will be a limitation. Somewhere you will struck. You will have a limitation. Beyond that, you may need not to, or you may not to process. You may not able to process it beyond that threshold. Will they adjust Swiggy if they are getting business of more than 100K request per minute? Will they lose that business? Will they say, hey, currently I'm handling 5K food deliveries, please come later? Now you are ordering for lunch, come by dinner, I'll be free. Will it work out? No, right? They will lose their business definitely. So instead of that, if they can move all this right into microservices instead of implementing like this, the same thing, imagine implemented as a microservice, not a module, as a service. If it is implemented, when we say service, it is independently deployable, manageable, developable, modifiable, everything, right? Again, it will be a separate application. One team will work on it, or one guy will work on it, and there will be separate deployment. Everything is separate. Now, not a single server this time. Each service will be deployed. Let's say if we have a Kubernetes cluster here in AWS. Just a minute. Hello? Okay. So if you have a something EKS cluster here, EKS or EKS, whatever you say. Azure Kubernetes cluster or AWS EKS or your own PC you have and Kubernetes you have. 1 minute, please. So here we can deploy them as services. You know the advantage, right? Each service can be deployed into each service can be deployed into multiple pods. This customer service can be deployed in 2 pods or 10 pods, depending on the how much traffic you are getting. Customer service in 10 pods, each service in like 10 applications. Parallelly, it will run 10 services in the background. If one service is having traffic, the load balancer will send it to another pod. Same code will be running in 10 pods. Imagine each service, if it is running in 10 pods. And Kubernetes is capable to increase the pods. Sir, 10 pods also not sufficient to me. You don't worry. Kubernetes will take care. Configure it. How many maximum pods you want? 20 pods? Configure it. What about memories or size? That you don't worry. AWS will take care. RAM, hard disk, that blah, 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 network. That's where the cloud is advantage to you. All the hardware, all the stuff will be taken care by your cloud. You need not worry. And your pods increase and decrease, your Kubernetes will take care. Every service, you can run it in whatever number of pods you want. Then will you lose your business here? No, right?
No.
That's the reason we are going towards microservices. How big advantage it is. Think like a business person, okay? You have the business. Will you lose your business? How many of you have one business? Any business? We definitely don't lose our business, right? When customers increases, any business it can be. We will increase our stock and we will sell it. We will try to get as much as revenue. So the microservices are giving such great advantages to you. Even AWS side also, if limited number of requests only we are getting, sir, it will automatically shrink your consumption of AWS. When huge request comes, then it will consume. As much as you use, that much only you are paying to cloud also, right? That is the main advantage in the cloud. You are not buying a big server, though it is a Swiggy. First month, if it is a startup application, first month they may pay 5K only because their revenue is maybe 1 lakh. Going forward per year, Swiggy if you're getting 10,000 crores revenue, maybe obviously they will have that much request to AWS. Per year, they may pay 1 crore to AWS. If your business increases, the consumption will increase. The business, if there is no business, there is no consumption. So that you don't need to pay bill. As you are using power at your home. If you use, If you don't use, need not to pay. That is the advantage with microservices we have. That's the reason everybody implementing applications as microservices instead of plain monoliths. You got it? And there are so many advantages. You are seeing from the business only. If you see from the development also, there are so many advantages. Some challenges also we can overcome them. We can overcome. But there are so many advantages from the delivery side also. If this need to be delivered as a monolithic application, it may take some time. Collaboration between team, merging code conflicts. 10 people, if they work on 10 modules and if they merge code together, they will fight literally. Why you overwritten my code is like this, your code is like that. Such fights will happen. When it might come to microservices, your microservice, you can play. Nobody will object you. Independent teams can be deployed, parallelly they can work, parallelly they can deliver. As simple as that. So there are so many advantages. There are some challenges. We can overcome that challenges. So that's why every application building in microservices only. So this is what I wanted to conclude. Okay, the types of applications what we can build in Java. Static applications, need not to talk. We can simply build them in HTML and we can load into Git and run. Git is the not only choice. I'm telling you that this is open source. Freely you can deploy. If you have 100 rupees, you can have a static app. Now coming to dynamic applications, you should have a backend database, blah, blah, blah. For such dynamic applications, if you want to build standalone, which is running in your machine, you can build by using simple CoreJava. If you want to access from web, you need servlets kind of stuff, but that is very difficult to write. So we go with Spring. It is easy. Anybody can implement. If you want to read data and process and save something like that, schedulers, Spring providing. Distributed applications, like big modules we have, and each module or each sector is having different business people. So their business and ideas and thoughts, everything is different. So they will implement as separate services in case if any communication required between those applications. Earlier choice is EJB and web services. Now in web services we have SOAP and REST. REST is a simple way. In microservices, almost 100% we will use 99.99% REST only. So those distributed applications become very minimum small applications. Instead of implementing modules based, we are implementing services, because server side limitations we will have. Beyond a threshold, we can't support customers. So that's where this Kubernetes and cloud concepts will help you to increase or to decrease your pods count, and they can do the load balancing. Though 5K customers, 10K customers, 1 million, 1 trillion, whatever number it is, it can automatically increase the value, decrease the value without losing any customers. Okay, finally, we are here. Okay, this is quick summary. Okay. Yeah, again, tomorrow I'll go back to Spring discussion only, as we started discussion yesterday, right? We'll start with Spring Core module. Okay, please complete the payments at least by tomorrow and get the regular link. Okay, and if you are not joined yet in the group, please join. Let me share you that link also, so that communication will become easy to me to update anything to you. If any questions, no, you can ask me.
There are also any demo sessions planned, sir?
I'll continue regular pattern only. See, almost it's a third, fourth day, right? So
Yes.
let us have some regular content. Let's start from the basics, word formation to like ABCDs to word formation, sentence formation, like that. Okay, step by step we'll go until achieving microservices portion. Okay, please join this group and feel free to ask if you have any questions. Just ping me.
Sir, are you available for a call post this session?
Uh, Maybe after 20-30 minutes. I need some break.
Okay, yeah.
Hmm?
So can you share your number, sir?
I shared the link here in the chat. You join there.